Welcome to this Oracle Code Online session focusing on Oracle's mobile development solutions. G'day, my name is Chris Muir. I'm from Oracle's mobile platform team. Now, one of the problems for new customers learning to use Oracle technologies is while we have a wealth of documentation and learning collateral, much of this focuses on very discrete topics within each technology rather than the bigger picture of how to fit an entire application together end to end. Now, I don't know about you, but when I started to program, I had the opportunity to stare over the shoulders of senior developers and watch them create an entire application end to end. As they added code to one part of a system, they often in sequence would have to build out the other end of the system to provide the necessary infrastructure. Okay, so only by observing and watching these developers did I start to understand what was needed to be built, the bigger picture, so to speak. So with this guidance in mind, for this session, rather than going through a bunch of slides, instead I want to run a practical demonstration of quickly building the code for an entire mobile app or mobile system running on Android and iOS using Oracle Jet, backed by Oracle Mobile Cloud Service, which is going to authenticate our mobile user, but also it's going to serve data from an on-premise server. See, end-to-end development. As a result of this session, you're going to see a lot of code and a lot of development, which I hope will give you a taste for Oracle Jet, specifically building mobile apps with Oracle Jet, and how it can plug into Oracle Mobile Cloud Service to talk to on-premise servers, end to end. Okay, alrighty, but for the purpose of this session, say we are working on a hypothetical sales application. Our salesmen are heavily dependent on the contact details of our customers. They often ring customers while they're on the road to break a deal while they're in the area. However, our customers' contact details are frequently changing. Customers come and go, so the sales team need the latest contact details from our on-premise client management system. Right, so how do we go about building this mobile application with Oracle Jet and Oracle Mobile Cloud Service? Well, let's start the overall application build with Oracle Jet. For this video, we're going to assume you already know a little bit about Oracle Jet, what its purpose is, and I'm also going to assume you've already installed the Oracle Jet tooling. If you'd like more details about how to install the tooling, the following two articles discuss the installation instructions for both the web and hybrid mobile version of Jet we're going to use in this video. Now, you'll need to follow the instructions in both articles in sequence. So once with the Oracle Jet tooling installed, via the command line, we can create our basic Jet application scaffold using Yarn. So here I'm calling the Yarn Yo executable. We then specify that we're going to use the Oracle Jet hybrid template generator, and this will create the basic scaffold of our application. Our application source code will be placed in the subdirectory called phonebook. We'll use the basic Jet template to create our empty application scaffold. We'll support both the Android and iOS platforms. The application ID will be com.acme.phonebook, and the application name will be Acme Phonebook. Once the Yarn generator is completed, it would be nice to test the basic Jet application scaffold and test that it's actually up and running. So to test this on Android, we can run our application in Android's emulator by first cding into our applications directory, then calling grunt serve, stating we want to run our app on the Android platform, and our destination is an Android SDK emulator virtual device I've already set up called myAVD. Now, the Android emulator can be slow to start, so I've accelerated the video so you can see the end result of our running application. Alternatively, if we want to see the same on iOS, I'll Control-C the running session in the terminal, then kill the Android emulator, and this time type grunt serve. The platform is iOS, and the destination is the default emulator, which equates to the iOS simulator. And after waiting a few seconds, we can see our basic app is now running in the iOS simulator too. And for speed, we can also run the mobile app via the local browser. So again, I'll kill the running session with a Control-C, kill the iOS simulator, and instead this time type grunt serve, platform equals iOS, and the destination equals browser. And very quickly, we now see the app running in my browser. One of the big advantages of running by the browser is it's easy to open the browser's developers options. So we can look at the source code, the JavaScript console, network calls, and so on, which all will help us debug the application. Moving away from the running application, let's now take a look at the basic source code structure. So here I'm going to open my favorite text editor, and under the source directory of the scaffold that we generated, we can see the index.html page, which is the main launching page for our app. The overall page has a bunch of code injected by the template, which for this video we'll skip over because we don't have a lot of time to cover all of this. Rather, for the moment, let's make a simple change. And between the OJ hybrid app layout content div, where our main custom page content is to go, we'll add a span tag to output a value from a variable message using knockout. If you're not familiar with knockout and its superpowers, I suggest you check out the following article, which will give you the lowdown on knockout and how the data bind attribute allows us to access JavaScript variables in the background. Now the index page is backed by the main.js JavaScript module, where all our state and logic for the index.html page will go. So in the main view model class, we can place the variable, your name, that our HTML span data bind attribute refers to. In knockout, an observable is a variable the page can bind to that will automatically be updated on the screen if the variable value is changed in the background without having to use jQuery to manipulate the DOM. On making these changes in our code, if we turn to the browser, we can see our changes are live or hot loaded and our little welcome message is displayed. Alrighty, with the application scaffold in place, we're ready to start building out our app to do what we really want it to do. So, at its simplest, our goal for this app is to show a list of customers and their phone numbers so our sales team can call the customers while they're out and about on the road. However, before we allow our users to see this list, we would like them to log in, supplying a username and password. Now, this is where Oracle's Mobile Cloud Service will come in, as it will be the remote repository of our application users that we want to give access to the phonebook application on our mobile devices. So with this in mind, let's first build the login page in our Jet app, then we'll hook in Oracle Mobile Cloud Service to derive the MCS users later. For our login, in terms of user interface components or UI components, you can imagine when the app opens, we immediately show a login dialog with a username and password field and buttons to log in and reset the fields. If the user enters an incorrect username or password, in addition, you can imagine we need to show an error message dialog that shows the login has failed. To back the login dialog, we'll need some variables to hold the username and password, as well as logic each for the login and reset buttons. For the login button, we'll first check if the username and password are empty, and if yes, we'll do nothing, waiting for the user to enter some values for both. Otherwise, if they are not empty, we will call Oracle Mobile Cloud Service to authenticate the user with the supplied username and password. If the username and password proves to be valid, we'll then hide the dialog and display the phonebook data. Alternatively, if the username and password proves to be invalid, we want to hide the login dialog and show the error dialog instead. Now, going back to the login dialog, alternatively for the reset button, when selected, we simply want to clear the username and password fields, allowing the user to enter new fresh values. Finally, returning to the error dialog, when the user sees the error dialog and they select the OK button to acknowledge it, we want to hide the error dialog and return to the login dialog to give the user another chance to log in. Okay, so with all this in mind, with the pseudocode in place, let's actually start building our application. First, let's build the login dialog in the index.html page. Now, when working with the Jet application, when you want to add UI components to your page, the Oracle Jet cookbook is your big friend. Now, we can find this cookbook at oraclejet.org. Then we select the cookbook option, which gives us access to the cookbook containing all the components supported by Jet and hundreds of recipes on how to use those user interface components. This is why it's so useful. If we look among all the UI components, we find there is a dialog component, which will be useful for our login box. On selecting this, you can see there are many different recipes available for dialogs. Now, specifically, we want a modal dialog. When selecting this option in the cookbook, it gives us a runnable example, which if we click on the button, indeed we can see this will be perfect for our login box in our application. Beneath this, we see example code for creating the modal dialog in our HTML page. Essentially, we need a div tag, which is mapped to the OJ dialog component. We can give the dialog a title, and we can specify if the dialog is initially visible when the page displays, which is good for us as we want the login box to be visible when the app first opens. In turn, the dialog is made up of a dialog body where we can add children components, as well as a footer section for our login reset buttons. In looking at the JavaScript to support the dialog, we need to add OJ dialog as a dependency for our module. And as the dialog contains buttons, we will also need to add OJ button. Within the example, we can see how to open and close the dialog programmatically. We simply call jQuery with the dialog ID, then the OJ dialog function with the open or close keywords. Great, so that all seems pretty simple. So let's copy the dialog code across to our actual page. With the code, let's change the title to welcome, change the initial visibility property to show, delete the existing body elements, and we'll leave the button for a moment. As we've added the dialog and its button to our page, we must add OJ dialog, and OJS button to the list of page dependencies in the main.js JavaScript module. Now, in this dialog, we want to show a username label, a username input control, as well as a password label and an input control. If we return to the cookbook, we can see under forms there are recipes for input text controls. Within the basic recipe is a label component with some text, where the label is mapped to an input text component, whose value is mapped to a variable value. Then in the JavaScript, you can see we need to add OJ input text as a dependency, and then to add the value variable, we simply add it as a knockout observable. Again, this all seems pretty simple enough. So let's copy the label and input component over to our page. And we'll add it twice, once for the username and once for the password field. From here, we'll change the component ID and map it to a variable username, and we'll make it required. We'll then change the label component so it's associated with the same username ID, and we'll change the label text too. Having done the username, we'll then repeat these steps for the password. As these components refer to a username and password variable, we'll need to add these to our main JavaScript file as knockout observables so the values can be stored somewhere for the application to access. As mentioned earlier, if you're not familiar with knockout or its observables, effectively by using knockout and calling the observable function, these variables are exposed so that our page can reference them and automatically see any updates too. Knockout is incredibly powerful and saves us a lot of DOM manipulation code via jQuery as a result. Finally, we'll finish with creating the login and reset buttons in our login dialog. When we copy the dialog across in the cookbook, it already included buttons, so I'll quickly modify this. First, I'll duplicate the button code as we need both a login and a reset button. Then we'll change the first button's ID, its label, and we'll specify that when it's clicked to call a method login click. If we go to the cookbook and look at a button example, here we can see a simple push button example where if we click on Mo, behind the scenes the button Mo has a knockout property click, which we'll call a method button click. Looking at the JavaScript, you can see the method button click, which performs the actual logic for the click. So we need to set up something similar. So So let's copy the click code and return to our page. As you can see, our method is called login_click. If we open our JavaScript module, we can then copy the example click method and change the code for our purposes. For now, we'll just substitute a simple alert message. In addition to returning to our buttons, I'll modify the second button to represent our reset button. As you can see in my page, I've referenced a reset click function, so I'll need to add that to my main JavaScript module too. Just as a reminder, we need to add OJS button to our JavaScript dependencies for this module, but thanks to adding the dialog example earlier that already had a button example within it, I've already done that, so I won't be doing that again. Great, so at this point we can actually test our application, which will provide a useful sanity check if everything so far is hanging together properly. If we return to the running application, we can see that it has updated itself to now show the login dialog by default. However, something is wrong. I can see the username and password label, but there are no actual input text fields. What could be wrong? If we open the browser developer tools, looking in the console, we see that the application is complaining that it doesn't know what OJ input text is. Oh, that's right. Of course I've forgotten. I need to add it to the dependencies of main.js. So, quickly returning to main.js, we can see OJ input text isn't included. That was one of the things I was meant to do earlier. So I'll just type it in, then save, and now when we return to the app, we can see the username and password fields are actually appearing. If we click the login button, we can see the associated alert message we coded, proving that the button and the function for the click is working. And if we separately press the reset button, we can see its alert message too. Okay, let's continue with adding our application logic. If we return to our wireframe and pseudo logic, you can see at this point we've achieved, well, we've added the login dialog with the username and password fields and the login and reset buttons. We've also mapped the username and password field to the appropriate variables, and the login and reset buttons are at least backed by functions at this point. Great. However, the functions are incomplete because we don't have the associated logic from the pseudocode. So let's work on coding the pseudo logic from them now. For the login click function, I'll copy in the pseudocode, comment it out, and we can use that as a guide for moving forward to adding logic to our actual application. We first need to test if the username and password observables are null or empty strings. And if so, we'll do nothing, awaiting the user to enter values for both. Next, we will call MCS to authenticate the user with their password. Now for the demo, just at the moment, we're going to hold off doing this, as we haven't set up MCS yet. So instead, for the moment, let's just add a Boolean check to see if the username and password equal hard-coded values Joe and the literal password respectively. This will allow us to actually test if the password logic is working before we integrate MCS. Now, if the result is true, we'll then use jQuery to close the login dialog by calling OJ_dialog_close. If the result is false, we'll then use jQuery to close the login dialog in a similar fashion, but then open the error login dialog to display the error to the user that their username and password is incorrect. Now, we haven't actually created the error login dialog in our index.html page, so let's do that now. Returning to our index.html page, I'll copy over the previous dialog code, then change its ID and change its initial visibility to hide. Next, we'll delete the body content and add the text string, the username or password is incorrect. Then delete one of the footer buttons and change the remaining button to an OK button. Behind the dialog, we'll add the code for the OK button now. We will copy in the pseudocode, which instructs us to write code to close the login error dialog, then show the login dialog to allow the user to try entering a username and password again. Then we'll quickly convert that pseudocode across, which instructs us to write code to close the login error dialog, then show the login dialog to allow the user to try entering a username and password again. In addition, we'll empty the username and password values, saving the user from having to clear these down themselves, which is always painful in a mobile app. Now, back in our running app, if we enter an invalid username and password, we can see the error login dialog is displayed. On pressing OK, we're taken back to the login dialog. Good. Finally, if we then press the reset button, we've still got the alert. We need to add code for this too. So again, we'll copy and paste our pseudocode in, and then we'll write over the top of it, where we simply want to reset the username and password. As such, this is simply the same code from the error dialog button function. Alrighty, back to our running application. So I'll enter a username and password, but this time press reset, and we can see the values get cleared down. If I then enter an invalid username and password, we then get to the error dialog. And on returning, if we then enter a valid username and password of Joe and the literal password, the login dialog disappears and we are now on the main page waiting to show the customer's details. Nice. That's our login page done, though admittedly we haven't hooked in Oracle's mobile cloud service just yet. Let's continue to build out our Jet application, creating the overall layout and components, and we'll add the logic for MCS in a moment. Now there is a reason I want to do this, and it's twofold. Firstly, I want to show you how fast Jet mobile developers can build up an application without getting tied down to a back end. But secondly, when we do add Oracle's mobile cloud service to our application, I want to show you how easy it is to add MCS as a back end without having to majorly restructure our application. Now, as a reminder, what we want to do once authenticating the user via the login dialog is to show the user a list view containing a list of customers and their phone numbers so our salesman can call them. As you can likely imagine from the Jet code seen so far, this requires we add a user interface component to our page, which sources its data from a knockout observable in the JavaScript behind the scenes. To construct a list view, once again the Oracle Jet cookbook comes to our rescue. Now we can see there is a section for list views with a number of recipes. Now I'm going to take a punt and say we want to use a list view based on an array. In the example, we can see it has a list of rows showing information about various servers. And as you can see, each row has an icon, a title, a number of labels, and their values. We'll want something a little simpler than that, just people's names and phone numbers, but this is approximately what we want. If we look at the source code, we'll find a simple UL tag mapped to an OJ list view component. You'll note the list view component says it gets its data from something called data source, which is a variable undoubtedly defined in our JavaScript module. It also says for each item that it's going to use a knockout template called server template. Now, a knockout template is simply a JavaScript script tag. Indeed, we can see the server template script tag below. What Jet will actually do in this case is for every element in the data source, which is an array, it will call the script. So think of this as a for each loop where it will stamp out results using the script. If we look in that script tag, we can see it will output for each item an li tag and a series of other child tags within that to print out the current item's values. Now I won't go into all the details here, I'll reserve that for a proper training course, but to say in the div here, you can see it is including a div, then a span tag, outputting the static string myWebLogic, then the current item's name variable. And further down, version of nodes and CPU and so on. Now where do all these values come from? Well, these are the current elements of the data source that the list view tag is iterating over to produce the list view components and its items that we see here. Okay, so returning to data source, how is that defined in our code? If we look down a little further, we can see data source is stored in our JavaScript code as an oj.array table data source, passed in a plain old array called data, which above we can see is a JavaScript array object containing all the rows of data that is shown in the list view at runtime. Sweet, so this seems pretty easy to add to our application. Let's add the list view UI logic or UI component to our index.html page first. So under our dialogues, I'll copy across the list view component code. Having inserted the code, let's make some changes to make it more suitable for our use case. We'll give the list view a more meaningful name, and same for the data source. We'll also change the template name to row template. I think it's more meaningful for what the knockout template does for us. Prints out rows based on the template. Having done that, I'll need to define the row template script. Now for the purposes of this demonstration, I'm going to cheat and not copy over the sample template from the cookbook, as the example has lots of tags in it. Instead, I'll simply copy and paste out of thin air this exact solution and explain it now. So here we have a row template script that the list view will print out for each element in the phone book data source. For each row, the li tag will have an ID of the current data source element's name element. This helps identify each row from each other when they're all stamped out on the page in case you want to manipulate a single row via the DOM. Within each row, I'll include a bunch of jet layout components. Now, the overall row is 12 columns wide. So with these layout components, the row will be split into two divs taking up 6 columns each. Then within each of those, we'll print the name and phone number of the current row of the customer from the data source that the row template is printing out. Nice, so that takes care of the UI components for the list view. Let's now create the data source behind the scenes and we'll hard code the customer names and numbers for now. So first, I'll declare an observable array for the phone book data source that will start out empty. Again, I'll cheat here and copy in the sample code and explain it rather than relying on the cookbook. Next, to populate the array, we only want the code to be called once the user has been authenticated. So I'll add it here. Now, eventually this code won't be hard-coded at all, but it will derive this data from MCS. But at the moment, we're building up our samples so you can understand each step along the way. Then, as you can see here, I'm adding a JavaScript object array of customer names and their phone numbers. Next, in order to supply the list view component the data in the form it wants it, we'll create an instance of oj.ArrayTableDataSource, passing in the array. This adapter class takes care of transforming arrays into the compliant data source for the list view component. Then I'll expose this data as a knockout observable. As we've added the OJ list view component and the OJ array table data source to our page and code, we need to add these as dependencies to our JavaScript module. Then we're done. So on saving and running our app, logging in, we now see the list view component showing our static list of customers from the array in our JavaScript module. Sweet, we're making some progress. So at this point, we have our Jet application up and running with all the UI components and JavaScript logic. Now, admittedly, the user's authentication in the phone book of customers is hard-coded, but we've got our app up and running visually how we want it to look from our mock-ups earlier on. Nice. So, of course, using hard-coded data is not going to cut it for a production application. We really want to authenticate the users against a real list of users and derive the data from our back-end systems. In order to achieve this, we're going to bring Oracle Mobile Cloud Service now into the mix. Oracle's Mobile Cloud Service is what we call an MBaaS, a Mobile Backend as a Service, essentially a mobile-flavored cloud-based PaaS. MCS provides a lot of different capabilities for mobile apps, two of which includes allowing you to authenticate users remotely, as well as build your own APIs, your own REST APIs, for fetching data from your on-premise servers and essentially serving them to your mobile applications. So, let's imagine you had an on-premise server that exposed the following data for customers via a REST API. And we want MCS to fetch this data and compose the data so the names and phone numbers are combined like this for our mobile application. Now, would you believe this is a really trivial example of Oracle's Mobile Cloud Services superpowers? It can do much, much more than a simple example. But the simple example is useful for teaching you how to use Oracle Mobile Cloud Service. In essence, we're using MCS like a service bus, a traditional service bus on-prem, but we're using it in the cloud to access one or more external and remote services. Some of them might be your services, or they can be other services provided by clouds, or even some of your customers' systems, or whatever. Now, we're using MCS, we're using it to orchestrate the data for our mobile app, which needs combined fields. And then we're on publishing an API for our actual mobile application to consume. Right, so in order to do this in MCS, what we need to do is the following. Firstly, we need to create something called a REST connector to connect to our remote REST on-premise service to expose the customer data to MCS itself. Then in MCS, we create a custom API with its own REST endpoints to allow our mobile app to access the data. In terms of implementation behind that custom API, we write Node.js code that will accept the REST request from our remote mobile application and then use the connector to retrieve the data from our on-premise server, modify the data to our own needs, our mobile application's need, and then pass that back to the mobile app. Now by default, our REST APIs in MCS aren't exposed externally, so we also in MCS need to define a mobile backend to make the API publicly accessible. And then finally in our mobile app, we actually need to write the code in our mobile app itself to call MCS. Okay, and as you remember, right, in the moment it's hard-coded. Okay, so let's do that now. First, I'll create the mobile backend, then I'll create the connector, and finally I'll create the custom API to call the connector, as well as exposing the API through the mobile backend. Alrighty, so here we have the Oracle Mobile Cloud Service user interface, where we will create the necessary artifacts. First, we will create a new mobile backend. We do this by selecting the hamburger menu, Applications, Mobile Backends, and select the new mobile backend button. In the resulting dialog, we'll give the mobile backend the name Phonebook and enter a short description, then OK. Once the mobile backend is created, note the settings on this screen, such as the base URL, authentication type, mobile backend ID, and so on. Later, when the mobile application has to call our API through the mobile backend, it will need those settings, so do remember this page. In order to model different mobile application platforms calling MCS, such as Android or iOS, within the mobile backend we need to create a client configuration. So to do this, we click on the Clients option, then New Client button, and we enter the name of our client, the platform, I'll start with Android, the app version number, the Android package name, then select Create. When creating the client, MCS will give us an application key. Again, we'll need this key later for our mobile app. As a Jet app can also run on iOS, I'll create a client to represent the iOS client platform too. Once created, we will be given a separate application by MCS that our client application will also need later. In order for our Jet application user to authenticate its user against MCS, MCS needs to source its list of users from somewhere. Now MCS can support connecting to a remote identity provider, but for the purposes of demonstration, let's just create a hard-coded user in MCS, which we'll use instead. To do this, we click on Users, New User, and then enter a username and email address as well as a name. Then we select Create. Now one thing I won't show you in this demo is MCS will create and send a temporary password to the user's email address. Now as I have to use a private email address to do this, I won't show you the temporary password. Rather, for the rest demo, just assume I've changed the password to something like Mobile1Star, and we'll use that password when required for the rest of the demo. Okay, so at this point we've configured the mobile backend, 2 clients, one for Android and one for iOS, and a user account. Now let's set up our API and connector to call the remote on-premise service that will serve all the customer data. Now, as the API is dependent on the connector, I'll create the connector first. In selecting the application's connectors option, then the new connector button followed by REST, we're presented by the dialog to enter details around the connector and remote on-premise web service, which will provide the core of our customer Phonebook data. Here we'll enter connector name of PhonebookCon and the same name for the API name, which will be used to identify the connector in the custom API code we'll build soon. As part of defining the connector, we'll specify the remote service's URL. And for demo purposes, let's assume it's served via the following URL. MCS then asks for a number of other settings for the connector, which we can leave as the default values for now. However, if we go to the test page, this provides a useful option for testing the connector itself. So here we can see the internal URI for this connector inside of MCS for the connector that our Node.js code will call, and then MCS will translate that into the external URL of our on-premise web service. In order to get the list of customers, I need to add the customer's resource here. In order to test the connector, MCS requires that we use the mobile backend and the user that we created earlier. Thus, from our remote service, we can now see the results. With the connector built, our last job is to build our custom REST API. Now in MCS, a custom REST API is made up of 2 parts. The API interface, which includes the resources and verb definitions for the API, and the Node.js implementation. We'll start with the interface first. To create a new API, we select the APIs option, then the New API button, and then the Express API option. In the New Express API dialog, we'll use the name phonebook, same for the API name too. Underneath, you can see the URL that this API will be exposed as to our remote application as we type the name. On entering a short description and create, via the Express API, we can then quickly create a new REST resource by selecting Resources, then New Resource. In the resulting wizard, we'll call the resource Customer, plural customers. The wizard then wants some sample payload data for the resource, which we can copy and paste in from earlier. Having done that, on the next step of the resource wizard, MCS recognizes the payload elements were made up of a name and phone field, both with type string, and it adds an ID field to act as a primary key for each field automatically. Finally, in the last step of the wizard, it displays what REST endpoints will automatically be created for us. In our case, get, post, put, patch, and delete for our customer's resource. On clicking Finish and Save, we can actually test our API as a stub. Selecting the Test button, the resulting test screen shows us all the endpoints which we can select and test against. And I'll take the default Get endpoint here. Select our mobile backend and mobile user, and via the result, we can see it returns the test data we just entered in the API interface definition. This is very useful as it allows our mobile developer to start using the API even though we haven't implemented any code in Node.js yet. Right, so the last thing we need to do is write the Node.js code for the REST API, which upon a request from the mobile app will fetch the remote customer phonebook data via the connector that we just created. To do this, we return to our API and select the implementation option. From there, we click on the JavaScript scaffold button, which downloads the scaffold of the Node.js code we need to fill in. And looking at the file system, we find a zip file which we expand, and it contains the following files. Of importance is the package.json file, which is our archive manifest file, and the phonebook.js file, where our Node.js code will go. The other files can be ignored. In opening the Node.js file, we'll discover it has functions that represent the verbs of our REST API, that is get, post, put, patch, and delete. These methods are the Node.js Express.js handlers that are called when a request from a mobile application requests the URI and specific verb. As you can see, the get /mobile/custom/phonebook/customers function already has some demonstration code in it. For the incoming request, the method determines if the request is of type application JSON, and if yes, the res object, representing the response, returns a HTTP status code 200 and one of our sample records as a hard-coded object. Now what we want to do instead is call our connector to call the remote service. So let me copy over the existing code with a new solution and explain how it works. The first thing we do is get a handle on the internal MCS server-side SDK, which makes working with the MCS services easier. With the SDK in hand, we can use it on the phonebook connector we just previously created. And as you can see here, we're going to issue a GET request from the customer's resource. And this will translate in a call to www.acme.com/resources/customer. The GET function allows us to define two callback functions, one for success and one for failure. For the success callback function, this implies the code was able to connect to the external service and return data, and it passes this data back in an object handler we call success. With the data in hand, we then can convert it from JSON to a real JavaScript object calling json.parse. We then determine the number of customers in the return payload. Next, in the loop, for every customer in the return payload, we extract one by one each customer from the old payload and convert the data over to the format we need for our mobile application. In our case, concatenating the customer's first name and last name into a single name field, as well as the phone number area code and phone number into a single phone field. We then push each newly transformed customer record into a customer array. And once the loop is done, return all the customers to the mobile app with a HTTP status success code of 200 as well. In the other get function callback handler, if the connector returned an error, we return this straight away to the mobile app using a HTTP status code of 500. The other file we need to modify is the package.json file, which is a metadata file for the JavaScript. As you can see, it includes things like the custom API name and its version, as well as a spot for any dependencies. Now, as our code has a dependency on the phonebook connector, we added here its internal URI and MCS, including the version number 1.0. Having completed our code edits, we then zip the directory up containing our files, and returning to the MCS UI user interface, we either drop the zip file into the implementation page or select it via the File Open dialog and upload it. When the file successfully uploads, we see, well, there's two versions of the implementation listed. The version 1.0 file we just uploaded and a mock version. The mock version represents the test data we placed in the custom API endpoint design, and we can switch between using the mock implementation and our own code by selecting either entry and selecting the Set as Default button. We'll stick with the new code for now. From here, like we saw earlier, you can now test the API, but with the real Node code. So again, we'll select the test button and select the customer's get endpoint we want to test. We'll select the mobile backend, set the authentication options, and finally the test endpoint button itself. And in the response, we can see a real payload returned from the API, which is fetching its data from the remote web service, transforming the data into the format required for a mobile application. Nice. So we've now built our MCS infrastructure. We have published a REST API that extracts its customer phonebook data from our on-premise server. The missing piece of the puzzle is our mobile app does not yet know how to call MCS to authenticate our user and access that phonebook data. So let's complete that now. In order to write or access MCS from our JET application, we can either write code to access the REST APIs directly, or to save us writing a lot of fairly tedious REST API code, we can use a client SDK provided by MCS itself to do the calls for us. So let's look into how we add the MCS client SDKs to our JET app, and then we'll add the remaining code. Specifically for our JET mobile app, as it uses Cordova under the covers, MCS provides the MCS Cordova SDK, amongst others, with libraries to make this a simple function call. To add the Cordova SDK to our app, we covered this in an earlier video, which you can review here. But the basic steps are to... So from MCS, we download the Cordova SDK and we unzip it. We then copy the mcs.js file, which is the main library, into our JApp's source.js directory. In the source.js main.js file, within the required JS config path option, we add the new MCS library. If you don't know what required JS is, here's an article to help you. We then create under the JS directory a new file, mcsconfig.js, with this code. This code will be used to initialize the MCS library when it starts with the right settings. To do this, within that file, we copy across the contents from the SDK, the Oracle Mobile Cloud config.js file, into the MCS config.js file we just created. Within the copy code, here we copy all the settings for the JET app to call MCS via the MCS SDK JavaScript library we've just copied in. Now in this demo, we're only going to use HTTP basic authentication for any calls from our app to MCS. So I'm going to cut out the options for OAuth, Facebook Auth, SSO Auth, and Token Auth. In turn, these options for Sync and Sync Express are not used in this video, so I'll cut them out too. From there, we'll copy in the MCS mobile backend settings we talked about earlier. Which includes the mobile backend name, base URL, mobile backend ID, and anonymous token. We also need to copy in the application key for the mobile backend clients. Now, however, as you remember, MCS gave us two, one for iOS and then one for Android. To facilitate this, rather than hard coding the application key, we'll make it derived from a variable of the same name. Now you'll notice this particular expression includes a call to a Cordova plugin called device and a function called platform, which can tell you if the application is running on iOS and Android. So that plugin isn't available to our applications by default, so I need to go back to the command line, cd to hybrid, and add the devices plugin to our application. Returning to our code within the MCS config function, we'll then need to add code to initialize the SDK. Finally, in the main.js file, we must also add the MCS config JavaScript file to the available require.js modules, and then add it to the dependencies of the main module. Great, so having completed this last step, our MCS SDK is now ready to be used in our applications. So because of that, we have two remaining things to do. Firstly, we need to, in our mobile application, rather than hard coding the user, we now need to call MCS to authenticate our user. Second, once the user is authenticated, we need to fetch the phone book data from MCS, the REST API that we built. So righto, return back to where we started, right back to the application code we wrote in Jet. I'm going to modify it now to do this. Back in our main.js file, because we've added the MCS config dependency to our code, we're now going to make use of it. So in our code, where we then hard-coded the username and password check before, we'll now replace it with this code to authenticate the username and password against MCS. That is a call to MCS config mobile backend authorization authenticate, passing in the username and password. This function provides two callbacks to respond to the successful authentication of the user or not. Now, if the user is successfully authenticated, remember we want to close the dialog and go to the main page. Otherwise, on a failure, we want to flip across to the error dialog. So we're just copying in the original code here. However, for success, we no longer want to fetch our data from a hard-coded array object. Rather, we want to fetch this from MCS. So now that we've authenticated the user via the MCS SDK, we can then call the mobile backend custom code invoke custom code JSON request method, passing in the endpoint and the operation. This in turn allows us to define a success and failure callback function. In the failure callback, we're just going to be lazy and add a console log error message. But in the success callback, we'll then provide the results to the list views data source that we saw right back earlier in the video. Okay, on saving our work, let's have a big drum roll to see if it all works. So, up pops the app. And when we log in, it's failed. I wonder why. If we open the Chrome debugger, which can attach to the Android emulator, we can see in the background that the application is hitting a cause error. So to fix this, we need to add the running app's IP address to MCS's security allow origin policy to add a cause exemption. Now, when a Cordova app runs on Android, this is 10.0.2.2 port 8000. For iOS, this is 127.0.0.1 port 8000. To make this change, we log into MCS's user interface, open the administration page, download the policy file, open it, and change the security allow origin policy to list these two addresses. On save, then upload the file to MCS, then once loaded, we're good to go. So back to the app, and we'll try the login again. And this time we get success. Here's the list of customer phone numbers, fetched from MCS, fetched from our remote service. Nice! I promised you a proper practical demonstration of building an Oracle Jet application, connecting to Oracle Mobile Cloud servers, connecting to an on-premise servers, end to end. All demonstrations in development, very little slides. I hope in seeing the whole end-to-end application coming together in this Oracle Code Online session, you've got a real taste for how easy it is to build Jet applications and to build MCS applications, hook them together to serve your on-premise data. Overall, I hope this session has been useful to you. My pleasure to present it to you today, and I hope to catch you in another Oracle video very soon.
The remaining time in this session is set aside for your questions. Please use these final few minutes to submit your questions via the Q&A widget. Less than 5 minutes remain for any final questions for this session. Please take advantage of the Q&A widget. Thank you for your participation. This session is now closing. Please select your next session.